right, welcome back to the discussion for 12.6, which is on the binomial theorem. Excuse the mask, I've been yelled at in the library 3 times now for not wearing it, so I gotta maybe whip it on as the librarian comes by and screams at me. But the binomial theorem is going to be useful for some future classes, probably calculus. If you end up in calculus, which I think most of you in pre-calculus would end up in calculus, otherwise you would have taken Math 120 or something like that. But it'll come in handy, so we'll take a look at it and do a couple of the problems here. It's not the easiest thing, but it's quite helpful if you can master it. So let's get to it. Let's take a look at problem number 1 that says use Pascal's triangle to expand x plus 3, or oops, x plus y, that is, to the 6th. Okay. So Pascal's triangle is pretty useful. It helps you, for small numbers, it helps you go through and create the coefficients for the expansion of this term. And the expansion of this term, if you didn't use the binomial theorem, would be taking x plus y, multiplying it by x plus y, getting a trinomial, multiplying that by another x plus y, and then another one, and another one, another one, until there's 6 factors of it. And that's time-consuming and obnoxious, really. All right, I give up on that. That's obnoxious, too. So we've got x plus y to the 6th. I can use Pascal's triangle. I'm just going to create one over here. It's just starts with 1s down in a triangular direction like that, right? But then any time there's 2 numbers next to each other, you add them, and in between them in the row below, you write that number, right? So the 1 and the 1 creates a 2, 1 and the 2 creates a 3, this 2 and the 1 creates a 3 as well. The 1 adds to a 0, which is 1. Right, so you get the triangular 1s down the edges of your pyramid here, and then each of these next numbers, the next row is just determined by the sum of the 2 guys above it. So 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4 again. And you'll note a symmetry, right? The first numbers then get mirrored by the last numbers. But let's keep going here. I'm going to need to make this small. No, I've got enough room. 1, 5, 10. 6 and 4 is 10 again. 4 and 1 is 5, and then the 1. And then 1, 6, 15, 20, 15 again, 6, and then 1. Hopefully you can see that. It looks like you can. Okay. Now I'm looking for the 6th row, right? That doesn't mean start here at 1, 2, 3, 4, 5, 6. In fact, this starts at your 0th row, right? So we have to count starting from 0. This is row 0. And then your first row, and then your second row, and your third row. In fact, you can find out what row you are by the second number in, right? 3rd row, 4th row, 5th row, 6th row, right? So this is the one I want, the 6th row, because I'm at a 6th power, right? So these are my coefficients, 1, 6, 15, 20, 15, 6, 1, for the expansion of this x plus y to the 6th, right? So I'm going to take this and just write it up because I need some room here. Here, my coefficients are 1, and then 6, 15, 20, 15, 6, and 1, right? And then the coefficients go in front of the result of taking x times x times x times x, and then x times x times x, and then a y, and all that. So really what I'm going to do is start this off with x to the 6th, and then the next term would be x to the 1 less, but I'm going to increase my power of y. I'm going to consider that there's 0 power of y here, first power of y here, second power of y on the next one, so x to the 4th y squared. But all of these are going to add up to 6. 6 plus 0 is 6. 5 plus the 1 is 6. 4 plus 2 is 6. The next one's going to be x to the 3rd, y to the 3rd, right? So my x is going to decrease, and my y is going to increase, right? I'm still writing this a little big, so I'm going to erase this and start over. Maybe start it here. But I'll end up with x to the 6th, and then I'll end up with x to the 5th and y, and then x to the 4th and y squared, and x to the 3rd, y to the 3rd, still running out of room here, x squared, y to the 4th, and plus, sorry, I tried, and then x, and there's no more x's on the last one, is x to the 0, and then just y to the 6th, right? So I should have all of these terms, and they should have those coefficients multiplied in. So 1, and then 6, 15, 20, 15, 6, and then another 1. And those are my coefficients here. 1 on the x squared, 6 on the x to the 5th y, and so on and so on. And it's quick and easy using Pascal's triangle as long as we didn't have to go down very far. Because you can see the further you go, the wider this thing gets. And so if you have to go to the 20th, that's obnoxious because that triangle is humongous now, right? All right, let's take a look at another one here. Oh, let's look at 3. 3 is a good one to look at. Three also says use Pascal's triangle, but now we have 2x plus 1 to the 6th. And so in fact I can still use those same numbers. They were 1, 6, I want to say 15, 20, 15, 6, and 1. I might be wrong. I think I'm not though. And so the only thing that's different here is now it's not just an x that gets raised to the 6th and then an x that gets raised to the 5th and whatnot. It's a 2x. And so I'm going to write each one of these terms as that 2x to the 6, y to the 0, or 1 to the 0, right? And then the next term is 2x to the 5th. And then 1 to the 1, right? 6 power, 0th power, my 2x is going to decrease in powers from 6, 5, 4, 3, 2, 1, 0, while my 1 increases in powers from 0, 1, 2, 3, 4, 5, 6, right? So let me again try to get this on one line. Hopefully you can see this. 2x gets raised to the 6, the 1 is to the 0, and then we're going to have 2x gets raised to the 5th, the 1 is raised to the 1, and then I get 2x raised to the 4th, 1 squared, 2x raised to the 3rd, going down, and 1 going up to the 3rd, 2x to the going down, so 2, and then 1 to the 4, and still didn't make it. Plus, I'll just return down here. Plus, then I get a 2x to the 1, and then a 1 to the 5th, and then I get a 2x to the 0, and a 1 to the 6th, right? So my 2x again starts at 6 power, 5th, 4th, 3rd, 2nd, 1st, 0, while the other one increases, 0, 1, 2, 3, 4, 5, 6, right? But all of these coefficients go in front. 1, 6, 15, 20, 15, 6, and 1. Right? But it's not just these coefficients because the 2x is raised to the 6, so there's a coefficient that comes out from the term itself multiplied by Pascal's triangle coefficients. So I just have to be careful with those. So I'm going to write this as 1, the 1 doesn't matter, but 2 to the 6, 2, 4, 8, 16, 32, 64. So this is 64x to the 6th. And this 1 doesn't really matter. 1 to the 0 is 1, 1 to the 1 is 1, 1 to the 2nd is 1, 1 to the 3rd is 1. So these 1s are not important, they're just inconsequential at this point. But here for the next term I end up with a 6 that gets multiplied by a 2 to the 5th. So that's 32, x to the 5th. So that's 6 times that 32 times x to the 5th. Same thing here, I've got 15 that gets multiplied by 2 to the 4th, which is 16, x to the 4th. And then 20 that gets multiplied by 2 to the 3rd, which is 20 times 8, x to the 3rd, plus a 15 that gets multiplied by a 2 squared, so that's a 4, x squared, and then 6 times 2x. And then a 1 times 2x to the 0 is just 1, so this last term is 1 times 1 times 1, so that's a 1. And now I just have to multiply these coefficients together. 64 is fine, it's just a 64, x to the 6th. 6 times 32 is 180 plus 12 more, $192. 15 times 16 is 225 plus 15 more, so 240. Maybe. I should probably check that one, but I'm not going to because I am. 15 times 16 is indeed 240. Yay for me. I can math. 20 times 8, 160. X to the 3rd. 15 times 4, so 60 x squared, and then 12x, and then 1. So we had to take into consideration that this 2 is going to bring in some pretty big numbers at some points and change these coefficients. So the coefficients in the end are this 64, 192, 240, 160, 60, 12, and 1. And again, in my opinion, still easier than taking 2x plus 1, multiplying it by 2x plus 1, and then another 2x plus 1, and then another and another and another. That's a nightmare. That's like this whole board 6 times over. Nobody wants to do that. All right. So that's the Pascal's triangle portion of this. Once we get to number 4, it starts asking us to evaluate the binomial coefficients. And that's essentially what these numbers are, where this 1, 6, 15, 20, 15, 6, and 1 come from. And there's some notation to explain the binomial coefficients. You may not be ready for that kind of notation. It's a summation notation. You'll hit that in calculus. But the idea here is if you have, we write it like this, in parentheses, just one number on top of the other. This is read as n choose r. Or sometimes you'll see it as from n choose r. Really means if you have n choices of something, how many ways are there to choose r of them, right? So you go clothes shopping, whatever, there's 25 different styles of belt, and your mom says, pick out 3. 25, choose 3. There's 25 possible choices, you get to choose 3. There's a lot of different ways to choose those 3, right? You can pick the first 3 or the first 2 and then the third, fourth one or whatever. There's a lot of different ways of picking those out. But this is what this means, or is one interpretation of it. But n choose r is calculated as n factorial. And factorial just means like that number multiplied by the previous integer multiplied by the previous integer multiplied by the previous, and so on and so on, right? So I have n factorial over r factorial and then multiplied by n minus r factorial in the denominator. So it's pretty easy to think of just taking n factorial, r factorial, but you also have to divide by the difference of the two numbers factorial, right? And that's to account for, I mean, this doesn't matter, this is probability, but that's to account for if you chose belt 1, 2, and 3, that's the same as choosing belt 2, 1, and 3, you know, those duplicate kind of items. But again, That doesn't matter. Excuse me while I die of coronavirus. All right. So, we're asked, I'm going to leave this part up right here, but we're asked in number 4 to figure out what 8 choose 3 is. Right, so for whatever situation this arises or comes from, you go to Subway and they say you have 8 different meats, choose 3 to make your sandwich. How many ways are there to make that kind of sandwich? And so I would just take the top 8 factorial, because that's the top gets factorialized. The bottom factorial, so 3 factorial. And then the difference, 8 minus 3 factorial. And so I'm just going to simplify this. I'll do this in a couple of steps just to, kind of show my thinking through this. But 8 minus 3, 5, so I have 8 factorial over a 3 factorial and a 5 factorial. Okay. Now, the last thing you want to do is throw into your calculator 8 and then factorial and then 3 factorial and 5 factorial, because those are big numbers, right? 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? So instead of doing that, let's conceptualize what's happening here and just say that's exactly what's happening. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. In the denominator I have a 3 factorial, so I have 3 multiplied by 2 multiplied by 1, but I also have a 5 factorial, which is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Since this is all a bunch of crap multiplied in the numerator and a whole bunch of crap multiplied in the denominator, I can cancel factors. The ones don't matter, they're just ones, but I can cancel a 2 and a 3 and a 4 and a 5. All of a sudden my numbers got much smaller. I have 8 times 7 times 6 in the numerator, 3 times 2 times 1 in the denominator after I've canceled essentially a 5 factorial out of both, right? But I can keep going. This 1, again, is not significant. Dividing or multiplying by 1 doesn't change anything. But this 3 and 2 are a 6, and so I can cancel out that 6, and I have 56 left over. That's it. So you go into Subway and they say, hey, we have 8 different kinds of meats. Build a sandwich with 3 kinds of meats. There's 56 possible combinations, ways of doing that. Right? But that's the binomial coefficient that you would find. And you would find this on expanding something that was raised to the 8th power. This would be the 3rd term n, would be 56. Let's look at number 8. So number 8 says find the coefficient of the term. We've got the xy to the 3rd term in 3x minus 2y to the 4th. Okay. All right. So if I expanded this out, again, I would end up with some x to the 4th, y to the 0, x to the 3rd, y, x squared, y squared, x, y to the 3rd. That's the one we're looking for, and then a y to the 4th term. Right? Okay. So the coefficients in front of here, right, each of these has a binomial coefficient of 4. The first one is 4 choose 0. The next one would be 4 choose 1. The next one would be 4 choose 2. And then 4 choose 3. And then 4 choose 4. So the one that we're interested in has that binomial coefficient of 4 choose 3. So that's the first thing that I want to do is figure out what 4 choose 3 is. And it should be 4, but let's do it. And you can think about this, the symmetry allows you to think about this way. If you're choosing from 4 items and you have to choose 3 of them, that's the same way as choosing one of those items to not be chosen, right? So it should be the same as 4 choose 1, right? Which should be 4 because it's the first number in and we're on our 4th row. But again, let's do it out. 4 choose 3 would be that top gets factorialized, the bottom is factorialized, and then the difference between the two, factorial. So that is 4 factorial over 3 factorial, but 4 minus 3 is just 1 factorial. 1 factorial is just 1. And so really, I just have 4 times 3 times 2 times 1 over 3 times 2 times 1, but again, multiplied by another 1. I can cancel the 2, the 3, the 1's don't matter, and I have 4. So 4 is my binomial coefficient, but that's not the coefficient in the end of this thing because I have this 3 and this 2 hanging out, right? So in the end, my number should be that 4 choose 3, the binomial coefficient, multiplied by this 3x, the whole term raised to the first power, and then the whole term negative 2y raised to the third, right? Don't lose your negative. If there's a minus in here, then that second term is negative. But we just found that 4 choose 3 is 4. So then I have multiplied by 3, multiplied by x, multiplied by negative 2 to the third, and then multiplied by a y to the third, just distributing that 3 in there. So negative 2 to the third is negative 8, so that and 4 times 3 is 12. Just clean up a little bit here. 12 times negative 8 is going to be negative 96. And so my coefficient is negative 96, right? So you have to be careful if there's numbers in here, they're going to mess with your coefficient. You can't just say, oh, it's 4 choose 3, which is 4. Nope, it's not, because there's other numbers that get cubed or raised to the first power here. Right? All right, hopefully that's helpful. This is it. That's the last section for this course. So I will throw out a final review video, and I guess that's that. Thanks. Bye.